Welcome to the Crazy Hat Chemist. So another video in intermolecular forces. In fact, this is the last video of this unit. Fantastic. So let's get moving. Bam! So today we're talking about the details of a phase diagram. I want you to take a look at this graphic very carefully. On the y-axis you have pressure, on the x-axis you have temperature. Okay, I'm going to point out a few critical points here for you. Pun intended. Okay, this is the solid phase. So this is read as like you read a non-digital clock. Sweeping, right? So solid, then liquid, then the gaseous state. Okay, and this is with this graph here. So notice that we have a red line, a green line. We actually have two green lines. One's dashed, one's solid. You can look at either one of these as it's an example right now. And the blue line. So notice that on the far left-hand side you have the solid phase, and then in the middle you have the liquid phase, and then on the right you have the gaseous phase. Okay, so there's a triple point. The triple point includes the solid, liquid, and gaseous states all in one at one single pressure and temperature. That's the triple point, and where all three different phases exist at that same time. Okay, the critical temperature is the temperature at which the liquid, there is no liquid that exists above that critical temperature. Okay, the critical pressure is the pressure which no gas exists above it. Okay, the critical point is the intersection between the critical temperature and the critical pressure. Okay, so at this, above this, in this corner there is the distinction. There is no distinction between liquids and gases do not have an exist, and that's a supercritical fluid in this section of that graph. Okay, if the slope is negative, then the solid is less dense than the liquid. So here's an example. This green dashed line, this slope is negative. So that means that the solid is less dense than the liquid phase. Okay, now the opposite is true here too. So if this is a positive slope, notice the solid green line, the solid is more dense than the liquid state. Okay, now we have gone over the states of matter. We got three states of matter. That's a solid, that's a liquid, that's a gas, right? And so we have done the inner conversions between those. Okay, melting is the inner conversion between the solid and the liquid state. So there's that line. Okay, and then we have this line right here. That's going from a liquid to the gaseous state. That's called vaporization. Then this line right over here, that's going from the solid state to the vapor to the gaseous state. That's sublimation. Then back over in the opposite direction is freezing, going from a liquid to a solid state. Okay, and then also in the opposite direction, we're going from the gaseous state to the liquid state. That's condensation. And then also in the opposite direction, we're going from the gaseous state into the solid state directly, bypassing that liquid state. That's called deposition. So you really need to pay attention to this graph here. It's really critical for you. Hopefully that makes sense. Okay, that was the last video in this series. I hope you enjoyed it. And don't be a shark, because being a shark is not a good thing. But giving me a thumbs up on that video would be a great thing. And subscribing to my YouTube channel would also be a great thing. So don't be a shark. Subscribe to my YouTube channel. And I'll see you for the next unit.